This screencast will introduce the features of the data extractor of the CODE project. The central aim of the extractor is to crowdsource the integration of unstructured data into the linked open data cloud in a data warehouse compliant way. There are several possible input formats, but for this example we will work with Excel files. The result of the overall process is a data cube formulated in the W3C RDF cube vocabulary. In this sense, a data cube is the foundation for further statistical aggregation functions. Auxiliary export formats like ARF data format are also possible. Throughout the complete process, provenance information is tracked whenever possible for data quality assurance. The application scenario is settled in the flood disaster of the city of Passau. In the following, we will integrate and merge two separate Excel files covering the water levels of the rivers Inn and Danube. The first step in the integration workflow is the optional authentication of the user by the help of OAuth. Currently, we are using the Mendeley profiles to track users. After this step, one will be directly forwarded to the upload stage. Here, we are selecting the Excel file for further processing. The central step is the selection of the data that should be processed. To ensure clarity, only the first 5 data rows are presented to the user. It is possible to show the complete table or to delete columns as well as rows. The Edit panel enables a user to select dimensions as well as measurements. In our example, we select river and timestamp as dimensions and water level as measurement. The following refined step makes it possible to conduct atomic changes to a value of a single cell. In the disambiguation phase, a semantic web URI is added to the table headers. The user is now able to select an appropriate concept or define one on its own. The disambiguation of the values of a dimension can be confirmed optionally, but will be skipped in this example. The last step before storage is the definition of the actual table structure, in particular the type of the dimensions or the measure type. Here, the selection heavily influences the applicable statistical methods. Meaningful information for label and description along with the provenance link of the dataset complete this step. The generated data can be now exported as N3 data, XML or ORF. Further, storage can be triggered. After the storage, the user will be forwarded to his personal page where every data cube is located, which has been already produced. From this point it can be visualized or merged with another dataset. In our example, we can now see the water level of the Inn throughout the complete flooding. A powerful feature of our tool is the merging of already existing data cubes. As one might know, the Inn at Passau joins the Danube from the south and the Ilz from the north. To have a global view on the disaster in regards of the water levels, a single diagram would be desired. To do this, one can simply follow the data cube merging in the profile page. After selection of an initial dataset, the second dataset can be chosen. There is also the possibility of data cube recommendation. A new label and a description conclude this step and the merged data can be visualized.